Bude to.
So, good morning. Now the session continues here in Green Room, and I will give you Petr Kalnaj and Jaromír Hořejší from Avast Software with a presentation of DDoS Trojan, a malicious concept that conquered the ELF word format.
Yeah, thank you. We would like to show you that DDoS attacks also involve the case when the executables have the ELF file format. And the outline is as follows. At first, we would like to describe our view of ELF malware threat landscape and the role of DDoS Trojans in it. Then we show some milestones in threats evolution. We describe also common characteristics of these malware pieces and how auto-start feature was implemented in samples found in the wild. We won't avoid infection chains and methods of intrusion. And DDoS attacks, those are not just bots. There are larger infrastructure behind them, and we've managed to collect various operation tools like bot builders and CNC panels, vulnerability scanners, source codes. So it seems that cybercriminals haven't tried much to keep them private. Then we describe main DDoS Trojans like Elknot, Mr. Black, and other whatnots, and we conclude with targets and a summary. For you to have a better insight in ELF threat landscape, just by looks of it, we prepared the visualization using G5 and Force Atlas 2 graph layout algorithm. We took 12,000 malicious ELF files as of September 2015, and we clustered them. So the nodes represented particular malware families clustered by the common signature, by the signature sharing common root name, and the sizes of these nodes correlates to the number of unique hashes. With that signature, edges are present if nodes share a signature, and we then colored the nodes in 6 categories like viruses, exploits, general purpose Trojans, DDoS Trojans, and so on. Actually, we don't want to have our data be contaminated, so we excluded truncated files and other files of no or very little interest, like potentially ELF components of potentially unwanted APKs. So it looks like this. And in the top, those tiny stars are perhaps the most sophisticated and most interesting. Those are general purpose Trojans that also caught attention of IT media like Darlos or Wirenets or some commercial spyware, APTs, Hand of Thief, and newborn stars this year, Linux Moose, Linux Mumbleheart by great papers by ESET, and Symantec's IfWatch. But the conquest is coming in purple. And we can see in the lower part the big stars representing Legion DDoS Trojans. And what are reasons behind that the star is giant? It could be that the name is too generic, like it's a Flutter or it's an agent, or it's a threat that is here for some time, like tsunami bots, those accumulated in time. Or, and that's the case of these DDoS Trojans, are coming from bot builders. So, some highlights in the evolution of threat. First documented DDoS attack happened in 2000, and we wondered what are reasons behind, why was the time appropriate, and we found a research paper that said that the internet took over the half of global communication in 1999. So these might be connected somehow. Fundamental reference for us, a paper in VB 2011, a survey of contemporary Chinese DDoS malware, What we miss in the title now is the word Windows. What was said in the paper, like nature of attack procedures and nature of victims, remain true. Needless to say that DDoS families we mentioned in the sequel also have Windows variants. Little did we know when first bot builder for Linux flooding bots arrived at our backend in November 2013, but things started to get more clear when a few independent security researchers started to report incidents on their blog posts. All these were connected with a family we dubbed, or is dubbed, Elknot. The latter one was more sophisticated variant that contained strings Bill and Gates. And then more reports come, Dr. Webb on Mr. Black, Kaspersky on GevGit abusing shellshock. Interesting milestone in December 2014, VirusTotal added file detail tab with parsed ELF characteristics. And in their blog post, the service acknowledged the increased importance of ELF malware awareness. A good catch by Malware Must Die in September 2014 about Xorddos family that we described in details a few months later. And China Z appeared on the scene the same month. Brian Krebs pointed out that Lizard stressor is a real danger for IoT devices. And then a few references that also refer to our work. The last one from Kaspersky, they show some numbers, and we were glad because those numbers confirmed our own partial findings.
So let's talk a little bit about common ELF characteristics, because ELF format is for Linux something like PE format is for the Windows, and for us there are like several interesting information in the header. One of them is the type of the header. It can be either type of the file. It can be either executable file or shared object. Shared object is the equivalent of dynamic linked library in Windows. Another parameter which we are always interested is the machine type. Usually starts with prefix em underscore, and then it follows the type of the architecture or instruction set which the binary is compiled for. So we can find like many different architectures for many different systems, from servers to some like in the embedded machines, routers, and so on. And among these architectures, we have like Intel 32-bit, 64-bit, ARM, MIPS, Super H, PowerPC, Spark, Motorola 68K, and so on. Then later in the header, we can see the segments, and each segment contains one or more headers, and these headers sections, and these sections are usually like specifically named and have some usually specific purpose. There can be many different types or many different names, but for us, the most important ones are the symbol tables and string tables, which contain names of imported and exported symbols. So when we do the reverse engineering, it's much easier if these symbols are not stripped and if they remain there, so we can see the names of the procedures, names of some of the variables. There is also section raw data, which is also interesting because there are some character strings which are used by the program. So not symbol names, just the strings which are inside. A little bit about like generic static properties of the Trojans. So they are usually like Trojanized flooding tools, and usually some parts of codes are shared between different malware families, because a lot of these pieces of malware have their source codes shared on some forums, on some source code sharing websites, and so on. So the cybercriminals get inspiration from one another. Debug information is often not stripped. So what I mentioned before, the reverse engineering is mostly, I wouldn't say easy, but it's quite straightforward. The supported methods are usually like volumetric attacks like UDP flood, TCP SYN flood, ICMP, DNS. Some most advanced methods also include DNS amplification attack. Another feature which we often notice is the killing competing resources. So basically when the machine is infected by the flooding tool, it might be infected even before with some other floodder. So the newly installed malware kills the old malware. So it doesn't use any of the resources. It doesn't use any CPU cycles, any network bandwidth. A little bit about the form. It's usually, it's in many times in plain form. So there's like no obfuscation as we know from Windows malware. But the only kind of way of obfuscation or packing is packing with UPX tool. Sometimes we notice that these UPX headers are somehow modified. So the modified magic values or checksums do not match. So the official UPX tool doesn't always work, but it doesn't mean anything for the malware. It still runs, it still does its job well, but it cannot be unpacked with the official tool, and it needs to be somehow modified to get even into these files. The difference between tool and Trojan is in the persistence. That the Trojans have added some persistence, and we noticed there are usually like few methods of getting persistence in Linux machines, either installing scripts to some path like /etc/init.d or rcn.d, which is the run level indicator, or it can be via modification of cron file, again in etc path. So how do cybercriminals work? So in the beginning, they have the builder for the malware. So they just run this builder, build the malware. They need to upload it somewhere. It's usually run on compromised machines on which is installed one tool which is called HTTP file server. We'll call it HFS. It looks like in the figure here, in the right part of this slide. They upload there the malware, and then they need to distribute it somewhere. So they run the port scanners on various IP address ranges, and depending on open ports, they can even either attack or exploit some vulnerabilities. There have been many examples of Elasticsearch vulnerabilities, shell shock vulnerabilities in Windows Server Service, Apache Struts vulnerabilities, or in case of port 22 for SSH, they brute force names and passwords. And many devices like routers are run with default passwords, so it's sometimes quite easy and it doesn't need too many checks to get into the device. Before I mentioned the HFS listings, but they are not only the malware pieces or the actual malware. We have found there a lot of tools, a lot of data files. Among them, for example, list of target IP addresses. You can see some screenshots here in the left. There are IP address ranges which are tried. In the middle screenshot, you can see that some of these IP addresses were scanned for port 22, which is opened. And in the right part of the slide, you can see some default passwords which were tried or which were found in this file. This is how their operation tools look like. These are examples of bot builders. They can be even simple, like in the left part of the screenshot, where you can build like different versions for Linux, 32-bit, 64-bit Windows, FreeBSD, and so on. On the left part of the panel, you can build even control panels tied to specific MAC address, and so on. And some builders are quite simple, like on the right part, that they contain sometimes even just the box for IP address and port. This is example of some CNC panels. This one is completely in Chinese because most of these attackers come from China. So this is the example of panel fully in Chinese. This is another example of the panel, this time luckily for us in English. Here in this case, in the upper part, we can see that this botnet has a size of 1, and it runs from the name of the operating system. It runs something on MIPS. Sometimes we even found the binaries for the HFS itself, like shared or hosted on these HFS panels. And these HFS listings contain one important or interesting thing for us, and it is the rightmost column, which contains or which has the number of downloads, how many times the file was downloaded. So it can help us to estimate the size of the botnet. So sometimes we can see there are like hundreds or thousands, so we can see that the thing is like bigger or smaller. Another examples of some tools, these are vulnerability scanners and exploits. The right one is some tool for Microsoft Server exploit. It's probably some third-party tool. The left one is struts, is a vulnerability scanner for Apache struts from China Z Group, or they were using it fully in Chinese. Another tools which we found, and we found many versions. This is, for example, SSH brute forcer. So there is the file. There is, you execute the file, and you give him file with IP addresses, and it tries to scan these IP addresses for SSH, and then it tries some names and passwords from the files, from the data files. And if found, you can notice the line in the bottom. If this tool succeeds, it produces the following output. There are the brackets, in the middle is the IP address, then something in Chinese, and then there is the name/password. The output of this tool is input to another tool, which we call SSH uploader. We found it as exe file, but it was Python script, so with some little bit effort, it's possible to decompile it even to its Python source code. And what it does is that it takes the output from the previous tool, and for each line, it parses out the IP address. It connects to the machine because it already knows the name and password, and it runs few commands. And these commands are specified in the command.txt file. It's in the right part, in the upper one, the screenshot. And in this case, it's quite simple. It runs 3 commands. First one is wget, then there is the path to HFS storage / name of the file which is downloaded. Then it modifies the attributes of this file, then it executes it. Then it disconnects from the device and goes for another one, and it can run forever. These are examples of port scanners they use. Some of them are, again, fully Chinese, like the scan port, the upper one, and the bottom one, Winec drop, again, looks like it's like TCP port scanner from some other third-party group. Now let's talk a little bit about some of the malware families. So the most prolific one is called Elknot, and it's available for several different architectures. We found binaries for Linux, 32-bit, 64-bit, the same for Windows, even for FreeBSD. It has simple command grammar, which has just 4 tasks. One is to start task, stop task, write fake configuration, send status. When you look at these for example, in Wireshark, there are just simple bytes telling like 01, 02, 03, 04, specifying the tasks. The builders are usually very simple, as you can see below. Sometimes just IP address or port, sometimes just port. When we get these binaries, we are usually interested in CNC server, address of CNC server, and it's usually hard-coded in the binary. And when you look to the end, we always search for the two short strings which had numbers, and sometimes between them are like minus sign, slash, or colon. And when you look at this small computation below, it takes the first character, subtracts 1, takes second character, adds 1, and so on. So from this very simple encoding, we can see the result and know what is the command and control server. Maybe we can connect to it, listen to it, and understand what targets it attacks. Again, like command and control panels are usually very similar. In the upper part is the list of bots which are connected to the botnet. In the bottom part, you can specify the target IP address, the port which it should attack, number of threads, length of the attack, and also some specification like which kind of attack, like SYN flat, UDP flat, length of the payload, and so on. This is another example for control panel for the same family. This time you can see that one machine is in the botnet running Windows XP.
Let's continue with families. Mr. Black is a DDoS tool with source code available online. We have seen a new extensions of this project that contained also features like auto start or the usage of encryption, the family is easily recognized by the presence of character strings like version X, hacker, deal with DDoS. The number of procedures for attacks and the number of platforms that are supported is quite robust, and we have seen a control panel named Sword Linux previously. GavGit family, also known as Lizard Stressor Tool, source code leaked in January 2015, and it contained both the server and the client side. Intrusion is done usually by brute forcing telnet login and abusing shell-shock vulnerabilities. This bot listens to these commands that serve for attacks. And we can say that GavGit is public enemy number one for embedded devices, because there is the widest support for architectures, and we've seen variants also for exotic ones like Super H or PowerPC or Motorola 68K. Another threat, interesting one, Xorddos. It's mostly danger for Linux servers because it attempts to intrude via SSH brute forcing. And the core of this threat lies in the installation script, which collects information about victim's system. And in case when a server side does not recognize kernel version, it sends an uploader that collects kernel headers. And the purpose of these actions is that the final binary that is a Trojan contains also a loadable kernel module, a rootkit whose purpose is to hide indicators of compromise. And this rootkit is based on an open source project called Suterosu that was also available. And besides already mentioned auto-start features in the beginning, this one also possesses a heavy one when this multi-threaded program repeatedly installs itself in multiple copies under random name into the boot directory and execute itself. So it's quite hard to terminate it via kill command. The name comes from the usage of encryption, XOR encryption, and it is done for communication and also for the configuration file. The purpose of this file is to list all rivals that need to be eliminated from the victim's system. And it could be based on various categories, like the hash of the file name, or the process that is connecting to a certain IP. And this is an extensive list of file names that are not friends to Xorddos, and most of them are the competing DDoS Trojans we were mentioning. So this is a screenshot from an experiment we ran. This is a Windows graphic user interface of CNC panel. We ran two bots, one on classic Linux on Intel architecture and one on QEMU emulating ARM. And we found out that they both spoke the same network protocol. So, and this is the result of the experiment. China had another project that was available on GitHub under the name DDoS client. So you see, there's no need to reverse much in this case. It's similar volumetric attacks and support for platforms. Some UPX compression involved, and they also have some panels with graphic user interface. This runs on the Windows, and one of these is just a web-based interface for controlling botnet. So we didn't listen to every CNC of every family we mentioned, but from those we did, we learned that the targets are mostly small or medium-sized businesses, like online gaming sites, casinos, e-commerce, or forums. And for these, profitability depends on the ability of staying online and mostly not hosted on major content delivery networks. But Xorddos was an exception it was confident enough to attack the infrastructure of large providers like Google Cloud or Cloudflare, Amazon Cloud, Acknowledgement technologies. And for the previous case, the effect of DDoS was directly observed because we've collected the lists of IPs of targets, and after some time we checked those IPs and service was up and running. So to conclude with some points, from what we've seen, DDoS Trojans could be considered as threat number one for servers and embedded systems running Linux. There are a variety of projects available on code-sharing sites, and so we could expect more projects that would wrap these or mix with these. Auto-start is a desired and often, or in some cases, advanced feature. Attack methods are roughly the same. And for the time being, we say that there are only little attempts to cover the functionality, at least by stripping of debugging symbols or by using classic or modified UPX. We confirmed that there's increased detection rates by AV solutions, but distributors of malware are careless about this fact. They don't switch. They don't use polymorphism at the moment. And what we said about targets. We would like to thank some people and Twitter entities that are listed here. We've seen Ben on a list, so hello Ben. And recently, a few days ago, a group of Japanese and German scientists notified that about their cool research published in May this year. They've built a honeypot based or able to communicate with IoT devices, and they communicated with really exotic devices like heat pumps and all of those infected, and in a month they've collected about 150 samples. With no surprise, lizard stressor tool was a majority of those, but there were some moose and also bots that were undocumented and mostly undetected at the time. So if you're interested in embedded malware, we really recommend this research. And I guess that's all from our side. If you have any questions.
Well, I think that because we started a little bit late, there is no space for questions, but I believe that the guys will be available through the whole conference, so if you have any question to them.
Pavel, sorry, we do have 5 minutes because we
okay.
started 5 minutes late and we will give you the whole half an hour.
Yeah. Okay, so...
Okay, three.
Sorry, 3 minutes.
Three.
So I take back my word. There are some questions here.
So you mentioned about...
just wait for the microphone.
Thank you. Hello, Jari Niemela from Elknot. Great work, thank you. So you mentioned that right now the malware authors don't do any kind of detection evasion. Would you think that that would be very likely, because that's probably is the next stage in evolution?
So the malware, it depends on which machines it is installed. Because if it is installed, for example, on some routers, they don't need to do anything, because on routers there is no AV solution and nothing like that, so they probably keep it as it is. But there are some families which are more targeting the Linux servers, or there might be some changes in the future. But I don't think for the embedded devices they will do much change in the future.
Any other question? Here in the back.
Nice talk, thank you. Could you clarify a little bit more the auto start feature you described? Give a few more details about it.
For auto start, it's like the persistence. So when the machine is rebooted, the malware starts again. And we found that there are usually like 2 main or 3 main types. They either put some script And in this script, it's just a small text file which points or which contains the path to the file where it is usually installed. So it's one option. It was option 1 and option 3 because there are like different paths depending on the Linux distribution it runs. It's like one case. Another case is modifying cron file. So cron file is the file which contains it's text file, and on each file, each line, there is the like name or path to the process, an interval in which it should be started again. So these are two main times which we noticed in malware.
Okay, so thank you very much for your presentation.